Hey, we're going to go ahead and review for the quiz. Quiz 4.1, which will go over 4.1 and 4.2. Let's take a look at this image over here. I need to go ahead and find a plane parallel to plane ACD. So remember, to name a plane, you need to have 3 points, okay? You need to have 3 points to name a plane. I'll go ahead and use a different color. This one's a little dark. Let's see, let's use something like this. 3 points to name a plane, okay? So, here is plane ACD. I need to figure out what's parallel to that, right? And the symbol for parallel is that right there. So, I can see that this shape is basically this shape here, right? It's the same shape. It's two faces that are never going to intersect, just facing each other, right? So this plane and this plane are parallel. I got to go ahead and name that plane there. Again, I need to have 3 points. So we can call this JKL. So plane JKL is parallel to plane ACD. Okay? Or if you want, you can call this, if you don't want to call it plane JKL, you can call it plane JNM or plane MLK, and so on and so forth. As long as you have 3 points, that's all that matters, okay? Number 2, a segment parallel to segment EN. So your answer needs to be a segment, of course. And segment EN, I'm going to go ahead and erase this. Segment EN is right here. Okay? And remember, with parallel, if I'm talking about parallel lines or parallel segments, they have to be on the same plane. Okay? So I can see that segment EN is right here, and it's on this particular plane, whatever I'm shading right there. So the plane, or not the plane, the segment parallel to segment EN is this, right? And remember, with parallel lines, they don't intersect, and they have to be on the same plane. I need to write that down. They don't intersect too. And don't forget, they don't intersect at all. So segment EN is parallel to segment DM. So I need those endpoints there. So DM. Okay, so that's my answer. A segment skew to segment CL. So CL is right here. And remember, with skew lines, or segments in this case, skew means lines that don't intersect and are on different planes, okay? But the problem here is that your answer needs to contain point E. So here is CL, and this is point E. I can say segment ED, right? ED is on this particular plane, and CL is on this plane, or this plane, okay? As long as that is not here and here, then you're golden, okay? Or you can say segment EN, that's skew to segment CL, or segment EA, that's skew to segment CL here. So yeah, those are the answers. As long as it contains point E, then you're fine. And now the last question here is for this portion, a segment perpendicular to segment ML. So here is ML, and then, perpendicular looks like this, right? And they intersect at a 90-degree angle. So one thing that I can note here is segment DM is perpendicular to segment ML. Okay, they intersect at a 90-degree angle. Okay, alrighty, let's go ahead and move on. One thing that I want to go ahead and do is I'm going to prepare you for the transversal types of questions. Okay, so I have, let's say that I have two lines cut by two transversals, and then I'm going to label this line A, B, and then this line here is C, D. Then I start labeling. This is angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, angle 8, angle 9, angle 10, angle 11, angle 12, angle 13, angle 14, angle 15, angle 16. Okay, and I'm going to shrink this a bit so I have some room. Okay, so I have parallel lines cut by two transversals, and we can assume, let's just assume that A is parallel to B and C is parallel to D. Now, what I need to go ahead and do is I need to recall the following. I need to recall corresponding angles, maybe alternate interior angles, alternate exterior angles, and same side interior angles. Okay, so just real quickly, corresponding angles, if I have parallel lines cut by a transversal, 1, 2, 3, 4, 5, 6, 7, 8. An example of corresponding angles is if you compare one region to another, if you were standing at 1, right, in this region, it's like saying that you're standing at angle 5 for this particular region, right? 2 to 6, sorry, this is a 3, by the way. 3 to 7, 4 to 8, right? So it's just basically like you're comparing one region to another and where you are particularly standing. Those are corresponding angles. Alternate interior angles, just remember that this right here, this is the parallel lines are cut by a transversal, right? So this is the transversal. And examples of alternate interior angles would be, well, 3 and 6, because they are opposite sides of the transversal, and they are also on the inside. So this is interior, this is interior, right? So these are interior angles, and 3 and 6 are opposite to each other. So alternate interior angles. If I were to look at 4 and 5, these are alternate, right? Because they are opposite sides of the transversal, and they're both on the inside of the parallel lines as well, okay? So alternate interior angles. Alternate exterior angles would be if I were to compare 1 and 8, right? Because, well, they are alternate, they are opposite from each other, and they are also in the outside of the parallel lines. They're outside of the parallel lines. 2 and 8, sorry, not 2 and 8, 2 and 7, they are also alternate exterior angles because both of them are outside angles, and they are alternate. They are opposite to each other as well. So alternate exterior angles. Same side interior angles would mean, well, it's in the name. They're on the same side of the transversal, and they're both in the interior of the parallel line. So 4 and 6, they are same sides, and then they're both on the inside. 3 and 5 are also same side interior angles, okay? So now the question here is, why do I have this? Well, I'm preparing you for the assessments and such, so let's go ahead and get comfortable with parallel lines cut by two transversals, okay? And we're going to keep these things in mind. So now I'm going to go ahead and delete that. And this is how you're going to break it down if you want to, be successful with this. Because I think it'd be best if you have space or have an extra sheet of paper. It'd be better if you just redraw what it's asking you. Okay, so for instance, if I were to look at this, okay, I have 16 angles here, and I ask you, oh, okay, well, let's take a look at angle 9 and angle 13. So where's angle 9 and 13? Here's 9, here's 13. Do you notice that 9 is part of this line here, and then 13 is part of that line here? And what do these two angles have in common? Well, they have, or they share, this transversal here. So keep that in mind, because we're going to go ahead and replicate that. So I have these lines that are parallel, and then this is my transversal, 9, 13. Okay, so all I did was just redraw it, right? And I just want to make it, I want to make my life simpler. So I'm looking at 9 and 13. If I were to stand at 9, right, or if I were to say, oh, I'm comparing this region to this region, if I were to stand at 9, well, it's basically saying that I'm standing at 13, right? They're corresponding just by looking at the position relative to each other. So 9 and 13, these are corresponding angles. These are corresponding angles. And corresponding angles are always congruent. Okay? So corresponding angles are always congruent. Let's go ahead and do another one. Let's say, so I did 9 and 13. I'm just going to mark that off on my notes. So I did that. Let's go ahead and do angles 3 and angle 6. So where's 3 and 6? So here's 3, here's 6. Notice that 3 is part of line A, and 6 is part of line B, and it's sharing this particular transversal, we'll call it line C. So let's recreate that. So 3 is right here, and 6 is right there, okay? So this is my transversal, that's line C, yes? Transversal. And just by looking at the relationship between 3 and 6, well, they are opposite sides. They are on the opposite side of the transversal, and they are both inside, right? Interior. So just by looking at this, it creates that weird looking Z, so you know that I'm dealing with alternate interior angles. And remember, alternate interior angles are congruent. Okay? Let's do another one. So we did angles 3 and 6. Now let's go ahead and do something like angles 1 and 12. Angles 1 and angle 12. Again, 1's right here, and 12 is right here. Going to go ahead and do the same process. So if 1 is part of this line and 12 is part of this line, they both share this transversal. So draw. Oops, sorry, I'm supposed to do this. And then they share this transversal. So 1 is right here, 12 is right here, right? Okay, so I have parallel lines cut by a transversal. And I know we're so used to having parallel lines look like this, but it looks like this time. So you're probably better off just rotating it if you want, or tilting your head, I don't know. But I can see that, I think this is so important that you know where the transversal is, right? So this is the transversal. And I look at it, I'm like, okay, so this is an exterior angle, and this is an exterior angle. And notice that these angles here are opposite from each other. They are opposite sides of the transversal. Looking at 1 and 12, this is what we call alternate. This is alternate, okay, exterior angles. Those are alternate exterior angles because 1 and 12 are opposite from each other, and they are both outside angles, okay? It's all in the name, y'all. It's all in the name. If you can draw the picture, label, and then determine which type of angles they are, then I think you're going to be fine for the quiz. Okay, so these examples are alternate exterior angles. All right, so let's go ahead and do some more. I'm not going to stop until we all understand what's going on. So let's go ahead and do angles 4, and angle 11. I think I should go a little faster now. So 4, this is 4, this is 11. 4 is part of this line, and 11 is part of that line. 4 and 11 share this transversal, so I'm going to keep note of that. So 4, 11. Okay, these angles are in the interior, and then they're on the same side of this transversal. Okay, transversal. And then, so these are same side interior angles. Okay, those are same side interior angles. And now let's go ahead and take a look at angles 7 and 15. So 7's here, 15's here. 7 is part of this line, 15 is part of that line, and they both share that transversal. So 7, 15. Since this is my transversal, if I compare one region to the other region, if I were to stand at 7, I would be standing at 15. And y'all, people forget about the corresponding angles, and don't let that be you, okay? Everybody remembers the alternate interior angles, alternate exterior angles, same side interior angles, but they forget the corresponding angle. Remember, corresponding angles is when you're comparing one region to another. It's wherever you are in this one location is basically the same location, but in a different region, if that makes sense. Okay, so here you are if you're standing at this little corner in region 1, then you're supposed to be standing in the same corner, but in that different region. So 7 and 15 are what we call corresponding angles. Okay, corresponding angles. All right, so now I got that. Let's go ahead and take a look at angles 12 and 13. I feel like I did angles 12 and 13, did I not? No, I did not. Okay, so 12, part of line A, 13, part of line B. 12, 13, both share line D as the transversal. So here's 12, here's 13. This is my transversal. So 12 and 13 are opposite, and they're both in the interior. So these are alternate interior angles. Alternate interior angles. Okay. Now let's go ahead and do one more. Angles 10 and angle 15. 10, 15, 10 shares line A. And then 15 is part of line B. And then they share this transversal right here, line D. So 10, 15. They are opposite sides of the transversals. They're on the opposite sides of the transversals, and they are both on the outside. So these are alternate exterior angles. Angles 10 and 15 are. Okay? So hopefully that makes sense. All right. So now let's go ahead and move on. I think we are now able to do these problems here. Hopefully you guys are comfortable doing these problems now. So let's go ahead and move on. My goal here is to solve for x, okay? Or y, or find the indicated variables, use your pink sheet or whatever. So I'm going to take a look at this particular problem, and I'm going to think, okay, well, I know that these lines here are parallel. Why? Because of these feathers. So then this has to be the transversal. Okay, so that has to be the transversal. So what I have to do here is I need to think how I'm going to approach this problem. Well, if I know that I have two lines cut by a transversal, and I can see that y in 114, so angle y and this angle here, right? Oh, sorry, this is not angle y. This is whatever this angle is that has, y degrees compared to this angle over here. Well, these are basically corresponding. If I were to compare one region to another, this is basically corresponding, right? So if you are at A, then you're basically at B. Or if I say, if you are at A here, then you're basically at B here. So with corresponding angles are congruent. So I can say that y is equal to 114, okay? And if y is 114, so here, this is 114, this also has to be 114 as well, all right? So now I can go ahead and move on and figure out what x is equal to. And, we've already talked about alternate interior angles, corresponding angles, same side interior angles, and alternate exterior angles, and so on and so forth. But we cannot neglect the fact that we have learned about some other things, such as vertical angles, if that will appear on any assessment so far. So vertical angles, remember, they're lines that intersect, and the angles across from each other are congruent. And if I were to, look at the relationship here, yeah, I got vertical angles, but we can't forget about this other thing, and it's called the linear pair. And linear pairs are basically two angles that are adjacent to each other, right? And they're stuck together, and then they add up. They're supplementary. They add up to 180 degrees, right? So if I were to look at this, particular problem, I can see that this forms a linear pair. This angle here and this angle here, they add up to 180 degrees. So let's go ahead and do my math. And I have my calculator next to me so I can figure out what to do, or figure out what the answer is. So to find the indicated variable x, right, I already figured out what y is. I need to figure out what x is, okay? So what is x? So to set up my equation, I would do x plus 12, right, plus 114 is equal to, remember, linear pair, they equal to 180, so that's going to equal to 180. So now I'm going to combine the like terms. This should give me 126, right? And then I set that equal to 180, and then I'm going to solve for x. So 180 minus 126, that is 54. Okay, so that's all. I found what y is, and I know what x is. That's all I have to do. Be careful. Make sure that you are taking a look at those linear pairs, if any. Okay, just make sure that you are looking for those linear pairs, if any. Now what I want to go ahead and do is I want to look at this particular problem now. Okay, so I want to go ahead and look at this particular problem. So what is my game plan? Alternate interior angles, alternate exterior angles, corresponding, so on and so forth. You can trial and error, and you can do it however you want. If I were to look at this and I was like, oh man, this is kind of like a repeat of what we have over here. Well, let's take a look, okay? So you can see that we have a linear pair. So if I do 3x minus 15 plus y plus 25 is equal to 180. What is the problem here? Well, I have two different variables where you can't combine them whatsoever. You cannot combine the like terms, and that makes it very difficult for you to solve for the indicated variables. So you can't use that at this time, or I don't know if you have to use it at all, but that's something that you need to keep in mind. You cannot use that equation, so you have to figure out what else that you can do. Well, let's see. Y plus 25 and 105, they are alternate, but this angle is on the inside, it's in the interior, and this one is on the outside, that's exterior. So you can't set them equal to each other. So now you have to form a play. Okay, so this is where you're going to have to form a play. there are two ways that you can approach to solve for y. One, you can use the corresponding angles postulate, right? If I have two parallel lines, if I have parallel lines cut by a transversal, if I compare one region to the other region, well, if you were standing here in this one region, then you're basically standing here at this other region, right? So you can call that y plus 25 as well, right? And then you can just go ahead and say, oh, this forms a linear pair. I can set them equal to 180, and I go 105 plus y plus 25 is equal to 180. Then I combine the like terms. I get y plus 130 equals 180. So y is equal to 50, right? That's awesome. You have y. And this is all because we were using corresponding angles and then moving on to linear pair theorem, right? That's one way to do it. The other way, if you want, is you can see if you wanted to, well, this right here also forms a linear pair. So if these two angles are supplementary, right, they're a linear pair, well, I can say that this is 75. Okay? Because 75 plus 105, well, what is that going to give me? 180. Okay? And now that I have 75 and I have this angle here, I can just basically see that these are alternate from each other. 75 and y plus 25, they're alternate and they're both in the inside. So they are congruent, right, by the alternate interior angles. So you can just do y plus 25 is equal to 75. And then if you subtract both sides by 25, you get y is equal to 50. Okay, so that's just me using the so I was using the linear pair, right? I was like, okay, I can figure out if this is 105, then this has to be 75, and then this and this, they're congruent because of the alternate interior angles theorem. So y is equal to 50. So there are ways for you to find the indicated variable. Okay, so now, what I have to do is I need to figure out what x is equal to, okay? So it seems like there are so many ways that you can do this, and I just realized that 3x minus 15 and 105, they're corresponding. They are corresponding, right? You're comparing one region to another region. If you were standing here, then you're basically standing here in this other region, on this other region or whatever. So you can set them equal to each other. I can do 3x minus 15 is equal to 105. 3x is equal to 1... What is that going to give me? That is going to give me 120. So x is equal to 40. And there you go. I just figured out what x is equal to. Okay? What's the other way? If you didn't notice they were corresponding, well, you can just, if you know what y is equal to 50, right? So then I do 50 plus 25, that's 75, and then this forms a linear pair. So you can do 3x minus 15 plus 50 plus 25 is equal to, actually, I don't need to write 50 plus 25 because I already know that's 75, right? Which is equal to 180. So 3x is equal to 60, right? That's 60, right? Yeah, that's 60 is equal to 180. So 3x is equal to 120. So x is equal to 40. Okay? So again, so many ways. As long as you know your theorems, postulates, blah, 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 then you're going to be fine doing these problems, right? I just showed you so many ways. There's not one particular way. Just be comfortable with the theorems. If you know your theorems, postulates, definitions, etc., then you're going to be fine, okay? Let's go ahead and take a look at this particular problem. This is just basically 4-2, right? So remember, if you have, like, let's say that you have two lines, you cannot assume that they're parallel, okay? Two lines that is cut by a transversal, not two parallel lines. Or these lines here, they are not parallel. You cannot assume. Then if the angles are congruent, then they are parallel. The lines that are involved are parallel, right? You can look at the pink sheets or the notes, the 4-2 notes, to get an idea. But really, this is so simple. It says find x so that A is parallel to B. That's your goal, okay? If these angles are congruent and they are alternate interior angles, then these lines are parallel. And I say that these are alternate interior angles because these are the only expressions that we're working with. And this angle and this angle here are alternate. They're opposite to each other, and they are they're in the interior, right? So they're alternate interior angles. And remember, with alternate interior angles, they are congruent. So then I take this and this, I set them equal to each other. And then I'm going to go ahead and solve. So this is 28 on the right hand side, and then I've subtracted both sides by 5x. I get 2x, so x is equal to 14. Okay, and that's all I have to do. I'm just finding x. Very simple.